Okay, so this is going to be an introduction for Module 2, Lesson 3 for College Prep Math 3. I'm going to talk a little bit about functions and function notation. Okay, so first let's talk about what a function is. A function is a relation, which is a set of ordered pairs. You can list it just by listing some ordered pairs like I have done here. You can also get a set of ordered pairs from an equation or from a graph. But the key thing here, if you're dealing with a function, is that every x value has exactly one y value that goes with it. And so this means that you can't have repeated y values that go with the same x value. So if I'm looking at these two sets of ordered pairs. Let's look at this first one up top here first. 4, 2, 5, 4, 8, 8, and 9, 2. This is an example of a function because every x value in this group of ordered pairs is unique. 4, 5, 8, and 9. All of those x values are unique. We don't have any repeats in there. That's what we're looking for to decide whether something is a function or not. Now, one thing I want you to notice here is in this set of ordered pairs, the y's do repeat. That's okay. You can have repeated y values, but what you can't have if you're going to be dealing with a function is repeated x values. So this is a function because all of our x values are unique, have a single y that go with them. Okay, the second set down here, -1, 4, 0, 3, -1, -5. This is not a function because we have repeated x values right here. That -1 value repeats in two different ordered pairs with different y values. If you have that situation, then you don't meet the criteria for something to be a function. Okay, the x values are repeated. Okay, so this is not a function. We can also talk about whether a graph gives us a relation that is a function or not as well. And it's pretty easy to tell. Like let's look at this left graph over here first. We call this a parabola. We'll be dealing more with these parabolas a little later in the class. But the way that we're going to decide whether this is a function or not is we're going to use this thing called the vertical line test. Okay, what I'm going to do is I'm going to draw a vertical line somewhere on my graph, somewhere to the left of my graph, and then I'm going to kind of in my head, I'm going to think about grabbing that vertical line and dragging it across my graph. Okay, and I'm going to think about, are there ever any points where this vertical line, as I drag it across, hit my graph more than once? And for this one, the answer to that question is no. This vertical line will never cross this graph more than once. So this is a function. We say that this is a function because it passes the vertical line test. Every vertical line I draw will cross this graph in at most one point. So this is a function over here with our left graph. Over here on the right, on the other hand, when we have a circle like this, if I'm going to think about whether it's a function or not, I can see it's not, because if I draw a vertical line, that vertical line hits the graph more than one time, right? In fact, any vertical line that intersects the circle at all is going to hit it more than once unless it's on the very outside edges. So this is not a function. Okay, so this is going to be a pretty quick and easy way when we have a graph to decide whether it represents a function or not. We're just going to draw a vertical line through any point. If you can draw a vertical line through any point on your graph and it hits the graph at most one time, then you're looking at a function. If you can draw a vertical line that hits that graph more than once, then you're looking at something that's not a function instead. So call that the vertical line test, a very easy way to tell on a graph whether you're working with a function or not. Okay, so I wrote the question, what is y when x is 2 at the top of the page? And the reason why I'm writing this is because this is a question that when you're doing math, you have to ask a lot. It's a very common thing that you need to figure out. You need to figure out your y for a specific x value. But guess what? We don't want to write this question out over and over again. It takes a lot of time, and we want a shorthand that lets us write this whole question out very quickly. And it's actually pretty easy to do once you understand this thing called function notation, the next big topic in this. We can ask this entire question with just a couple of characters if we know what we're doing. So what is y when x is 2? We replace this as shorthand that looks like this. F of 2 is the way that we say that, okay? So what does this mean for us? Well, let's look at what a full function notation equation will look like, and we'll talk about how to use that a little more. Okay, so I'm going to give you a function, f of x equals negative 3x minus 1, and we're going to use that for a couple of different things. The first thing we're going to do here is we're going to find f of 2. So if we're going to find f of 2 for a function like this, what we have to notice is what we've done here is we've replaced the x with a 2 in our function notation statement. And what that is doing really here is it's giving us an instruction for what to do for the whole problem. If I replace the x with the 2 in the parenthesis there, I'm going to replace all of my x's with 2. So f of 2 is going to be equal to negative 3 times, I'm going to replace that x with the 2 on the right side as well. So negative 3 times 2 minus 1. And then I'm just going to work that out. So f of 2 is equal to, well, that's negative 6 minus 1 equals negative 7, okay? And so what this does is it gives me an x and a y value that I can put together to get an ordered pair. That value inside the parentheses, the 2 over here, that replaced my x. So that is the x in my ordered pair. And then this function notation statement, this whole thing right here, this f of 2, that is another way to write y. So f of 2 is equal to negative 7. We just did our work to show that, right? So that negative 7 is going to be my y value here. So I can get an ordered pair from this statement. 2, negative 7 is going to be part of my graph. If I was trying to graph this, I could use this as a point to graph this, okay? Similarly, if I'm trying to find f of negative 3, again, I replace the x with a negative 3 in there. So I want to plug that negative 3 in for x. And then I just want to work it out. Negative 3 times negative 3 is 9. 9 minus 1. And I can get an ordered pair from that as well. Again, the x value was replaced with the negative 3. So negative 3 goes in here. And then my answer that I get when I do my work on the other side, that's my y value that goes with that. Okay, so we won't always ask you the question that way. I'm gonna still work with the same function, the same f of x equals negative 3x minus 1. Ask the question in a slightly different way, and I'll just warn you right now, this is a question that is very commonly missed on our tests, okay? The question now says find x if f of x is equal to 5. The common mistake is people just plug 5 in for x in the equation, but I'm not giving you an x value here. You'll notice the x is unknown. It's not filled in. I'm actually looking for that x. That's what I'm trying to find, right? So this 5 is an f of x value, okay? And f of x actually can go over here in my function, right? If I plug that 5 in for f of x, I'll have a statement like this. Okay, and that will give me something that I can solve for x to figure out what the actual value is here. I can move this 1 over to the other side, get rid of that, divide, and we can get the x that goes with that. And if I want to make an ordered pair out of this, well, that negative 2 is an x value, so it goes first, and then the y is my f of x value, which we gave you in the problem. It's that 5 there. So negative 2 and 5 is the ordered pair that goes with this. So don't go too quickly on these and just plug that 5 in for x. It's not what it's giving you. F of x is 5, so that means that's a y value, and it's going to go and replace the f of x in my original statement there. Okay, so the last big topic to talk about in this particular lesson is the domain and range. If I'm looking at a set of ordered pairs, like I've got here the 2, 5, 3, negative 3, and 6, 4, if I want to talk about the domain, well, what the domain is in general is the set of all of the x values that show up in your in a relation like this. So the domain for this particular set is 2 and 3 and 6. It's just a list of all the x values that show up in that list. The range, on the other hand, range is a term that is telling us that we're going to be dealing with the y values. So the range of a set like this is just going to be a list of the y values. So 5 and negative 3 and 4 are going to be my range here. Okay. Now we can't always figure out the range for a set like this because it's not always finite. Let me show you what I mean. Okay, so we'll often ask you to find the domain and range for a graph like this. And what you can't do on a graph like this is list values, right? Because if we tried to do that, there's just an infinite number of them. There's an infinite number of points that make up this graph. So what we have to do instead is we have to use this thing called an interval to get what the domain and range are. And we have to remember what we're talking about here. When we're talking about the domain, we're going to be talking about the x values, right? And if I'm thinking about the x values of a graph like this, I'm thinking about working my way across the graph from left to right. If I want to start on the left, well, I just can't. If I track this thing over here to the left, it just keeps going, and it keeps going to the left forever. Okay, so there is no leftmost point on the graph, right? And when things continue on forever in math, we say they go to infinity. And since this one goes to the left, we say it goes to negative infinity. Okay, and then we're going to work our way across. We're going to try to find the rightmost point on this graph to finish our domain, left to right, since we're dealing with the x values here. But again, it's very similar. We're going to be going to the right, and we're going to the right forever. So this graph goes from negative infinity to positive infinity. Now, we're going to use at the end of our interval and the beginning of our interval either a parenthesis or a square bracket. Parenthesis means that the value is not included in our domain, and square bracket means that the value is included in our domain. In this particular case, you can't include infinities. Infinities are not values. Okay, they're just concepts that tell you that it just keeps going forever in both directions. So we're just going to use parentheses for both of those. Okay, last, if we want to do the range, first off, we've got to keep in mind what we're shooting for here. The range is the set of all the y values for your set. So domain means x, range means y's. And y's are going to run from the bottom of our graph to the top of our graph. And unlike in the first one, we didn't have a leftmost point or a rightmost point when we were thinking about the domain, but we do have a bottommost point in this function, right? It's this 2, -3 point that I've labeled down here that's at the bottom of our graph, right? So our range actually does start down there. We want to be careful here. A lot of people make the mistake of using the value 2. Don't care about the 2 at all, because when we're talking about range, we're talking about the y value. So that bottommost y value is -3. That's where our range is going to start. Okay, and then we're going to work our way up to the top. And in this case, similar to the domain, this thing goes up forever. It doesn't really matter which path you follow, left or right, because we're going bottom to top. This thing goes up forever, and so we say that this thing goes to infinity. Now, -3 is a real point on our graph that we really want to include in our range. So we're going to use a square bracket to indicate that that value is part of our range. The parenthesis, on the other hand, is never included, so that will always get, the infinity symbol will always get a parenthesis that goes with that. Okay? So this will take a little bit of practice. Feel free to let me know if you have any other questions or you want to see some more examples. And let me know what I can do to help. You guys have a good day.